Let's dive into another section of trigonometry, and that's the section of trig graphs. So we've done algebraic functions, and then we've done trigonometry, and now we see that we can actually bring the trigonometry that we have onto the Cartesian plane, and there are three trig graphs that we need to know. So we've got the sine graph, the cos graph, and the tan graph. We'll have a look at each of them and just identify some of the main points that we need to know. So most of your teachers will talk about what is known as the parent graph, which is what's drawn here. So in the sine graph, we have a couple of key points. So at the origin, sine starts at the center. So although the spelling is not the same, the alliteration does help to remember that, because sine and cos do look quite similar. Okay, the next important point here is 90 and 1. Then we've got 180 and 0, 270 and minus 1, and finally 360 and 0. And if you can remember these key points on this parent graph, you will actually be able to sketch it and apply and then transform this basic graph. So rather than having to study a whole load of theory, you can actually, through understanding, sketch all kinds of variations of this sine graph. Another thing that's very fascinating, if you just look at the positive side for now, is you'll see if you were to picture our cast rule, remember we almost take this Cartesian plane then and we draw it in 4 quadrants. And if you think about that now, have a look at the sine graph and what it's doing. In this first quadrant, it's positive. Why am I saying it's positive? Because it's above the x-axis. So all the y values there are positive. In the second quadrant, it's positive. And then in the third and fourth quadrant, you'll see it's below the line, so negative. Now think about this cast rule. And in the cast rule, we know that sine is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. So it's just interesting to realize that everything is actually linked, and that a sine graph, you will often actually hear your teacher as you do an equation or as you tackle an identity, they'll say, but picture the graph. At 0, sine is 0, or something like that. And this is kind of what they're referring to, is the fact that you can take this Cartesian plane version here with the 4 quadrants and you can unfold it so that degrees become your x-axis and then your function value is on the y-axis. And it's just another helpful way to look at this kind of trigonometry. Next up, let's take a look at the cos graph. So the cos graph is very similar to the sine graph. It's just shifted a bit along the axis. So let's have a look just in these positive first 4 quadrants and see the important points we need to know on the parent graph. So at 0 degrees, cos is 1. At 90 degrees, cos is equal to 0. At 180, it's a minus 1. At 270, it's 0. And then there at 360, it's 1. Okay, so again, some important points on the parent graph to remember so that later on we can actually adapt this graph and make some changes. And just when we thought we got the hang of things, we were introduced to this tan graph, which is a very interesting graph indeed. So the tan graph, it's also a wave, but it's a wave that has asymptotes in it. Okay, now think about tan. Tan is equal to sine theta over cos theta. And so basically, wherever cos is equal to 0, tan is going to be undefined. And so if you picture your cos graph here, you'll remember cos was equal to 0 there, and cos was equal to 0 there. And so that's why they are asymptotes. And like I always say, so much better to understand why than rather just learn things. But it's super important. The minute you have a tan graph, that's what I want you to do, is to draw these asymptotes and label them. We do have some important points on the parent graph that are helpful to know. Again, like the sine graph, the tan graph starts at the center, so 0 and 0. And then because the tan graph is going to go on and on and on forever till infinity, we like to look at this point here, which is at 45 degrees and 1. So 45 degrees and 1, and you are expected to plot 1 extra point, because usually you'd have some kind of axis point here that's labeled, but because the tan graph has these asymptotes, we need to plot an additional point over here. Okay, and then again we've got the 180 here and 0, 360 and 0, and then super helpful just to plot these in between points. So 135 and minus 1, 225 and 1, 315 and minus 1. So if we consider these graphs now, the sine, the cos, and the tan graph, in the past, we just had two changes. We had a change in a value in each case, and a change in q value in each case. And both of those were directly related to the y values. So by changing the a value in these equations, you are resulting in either a vertical stretch or a squash, and by changing the q value, it will result in a vertical shift. So like I said, it's all linked to changes in the y values, which means they are all up and down types of changes. So let's have a look at an example to refresh your memory. Here we are asked to sketch the graph of y equals 2 tan theta minus 1. So straight away, I can see, okay, it's going to stretch, and it is going to shift down 1 unit. Okay, so that's because I understand what the equation is doing, I can interpret. So my q value is minus 1 and the a value is 2. So if you have a look here, faintly, I have just popped the standard tan graph in place. Okay. The other thing we need to do at grade 11 level is we need to start getting good at checking the domain that they've given us. So they want us to draw it for theta is an element from minus 180 up to 360, which means that everything outside of this minus 180 here doesn't get drawn. So I'm not going to draw any of that. I'm only going to draw for the domain that they have specified over there. Okay, that's the first thing. Now I'm going to have a look at my parent graph, which is nice and helpful here. It's dotted in yellow, and I'm going to start adapting that. Okay, the other thing that I said earlier is the minute you have to draw a tan graph, get into the habit of popping those asymptotes in and labeling them. So theta equals minus 90, theta equals 90, theta equals 270. Okay, so there they are, already drawn, and now we are ready to start adapting. So what I need to do is I need to take every y value that this graph represents, I need to multiply it by 2 and then minus 1. Okay, so the first thing we're going to do is we're going to say here, my parent graph is at 0. 0 times 2 is 0, minus 1. I'm going to plot my point over there. All right, next up, we're going to take the tan graph, which is here at 1. 1 times 2 is 2, and then we minus 1. So it looks like we end up in the same place, but not to worry. The graph is going to stretch out. Okay, and then we follow along, and we're going to take this point. It's minus 1. Minus 1 times 2 is minus 2, and then minus another 1 takes us down there to minus 3. Okay, 0 times 2 is 0, minus 1 takes us down there. Then we're going to look at 1. 1 times 2 is 2, 2 minus 1 is 1. And we're going to do that for all of the points. And now I can draw my tan graph. Okay, so there. And then don't forget, we need to label that point. That's at 45. And we should label our graph that we've been asked to draw. Okay, so there we have it. A vertical stretch. It's now stretched by 2. And then we've shifted it 1. Okay, and in our next video we're going to dive into how this affects amplitude and period and all that kind of thing. But for now, we just need to understand how to sketch these graphs. Alright, so in grade 10 we learned about the effects of A and Q, and those were all linked to the Y value. Now in grade 11 level we are actually going to start to see the effects of B. So multiplying our theta or our x value by something, and p values, okay, which is going to be a shift. Okay, and both of those, if you look at them, they link to what is represented on the x-axis here. These should be thetas. This is a theta graph according to the equation. Okay, and so both of these are linked to theta, which means they are going to make or they're going to have an effect that works from left to right, or it's going to be horizontal. Okay, now if we change the b value, that's going to result in a horizontal stretch or squash, and if we change the p value, it's going to result in a horizontal shift. Okay, and this is very similar now to when we were doing algebraic functions. These ones, you need to almost think in the opposite direction. So if b becomes a value of 2, then my x values are actually going to half in each of these. And if this p value is like a positive 30, we are actually going to be moving to the left. So let's dive into some examples and make sure that we know how to tackle these questions. Sketch the graph of y equals cos theta over 2 plus 2. Okay, so what's happening here is this is supposed to be a horizontal stretch. Okay, stretch or squash, but because this is 1 over 2, that means it's a half. So I need to actually multiply by every x value by 2, or every theta value, because theta is the unknown here. Okay, if we check the domain, we need to draw for the full minus 360 to 360. And so what we're going to do now, this is also now a grade 10 change here, just added to the mix. So we're going to change, this is called a period change, which we'll look at definitely in much more detail in our next video. But we're going to change the period, and we're going to shift it up 2 places. Okay, so like I said earlier, we need to think in opposites. So what we're going to do is we're going to divide by a half. Okay, and if you do this, you'll be able to get all of your points in the right spot. And so let's do that. And these are, again, our theta values that we need to divide. Okay, so let's start here at the center. 0 degrees divided by a half is just going to be at 0. And then we want to plus 2 over there. So we're going to end up at 3. Okay, now we're going to move right along. Here's a 90 degrees. At 90 degrees, it's 0. So to my x value, I need to divide it by a half. So that's actually going to take me to 180. Okay, and you can check me on your calculator. Dividing by a half is the same as timesing by 2. Okay, and then we need to shift it up 2 places. So we're going to plot our point there. Next up, we are going to be looking at, so we've done this one and this one. We're going to look here and 180. Okay, again, we're going to take 180 and divide it by 2. So that's going to take us all the way to 360. And then we're going to take our minus 1 and we're going to plus 2. So 1, 2. That's going to take us up to the positive 1 there. Okay, and if your teacher's already done trig graphs with you, you'll start to say, well, this makes sense because I know that the period needs to change. So this wave needs to actually stretch out, which is why now we used to have a full wave here. Now we've just got half a wave. And so then we can do the exact same thing and we can complete in the opposite direction. So we can say, well, then over here I can make a mirror image, and over here I can make a mirror image. And there we have the graph. Y is equal to cos a half theta plus 2. Okay, and so what happened was I did everything in opposites, and so instead of it being a full wave in half the amount of time, it ends up being a full wave in double the amount of time. So it used to take us from 0 to 360, so 360 degrees to do a full cos graph. Now it's going to take us double the amount of time. I'm going to need a full 720 degrees to make a full wave here in this cos graph, and then everything was shifted up 2 units. Now the best way to get the hang of these things is to practice, 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 practice. But if you are feeling stressed, you can use your calculator to help you along. So you can, in each instance, many of the calculators now have a table function and you can plot a whole load of points all at one time. But what you can do is you can just substitute in a minus 360 into this equation, and that'll work. You'll be able to work out what is the y value and you'll get an answer of 1. And then you can substitute in minus 270. You're not going to get a very nice answer there. We can see straight away. Then you can substitute in a minus 180. So if you type in cos 180 over 2 plus 2, you'll end up with an answer of 2, etc. And so you can plot this point by point if you are nervous that you're going to make some mistakes by adapting the parent graph. Okay, one last example for this video. We need to sketch the graph of y is equal to minus sine theta plus 30. Okay, so I'm seeing again two changes. There's a change here to the a value, okay, minus 1, and then there is something being added here to theta, so that's going to be a shift, and it's a plus 30 degrees, so I can tell you straight away we are going to shift to the left. Okay, let's have a look at the domain they've specified there, from minus 270 to 270. So I don't want to draw anything outside of that domain. All right. Now, what does this minus mean? This minus essentially means a mirror image about the x-axis, or in this case, the theta axis. Okay, so it's going to reflect, it's going to become an upside down graph. Okay, so let's start and take each point. And again, I like to start at 0, okay? 0 degrees, and then we're going to move 30 to the left. So we are now going to be somewhere here, and then you can't really mirror that if it is exactly on the axis. So we're going to leave it just there. Okay, now let's take 90 degrees and move that 30 to the left, and then, remember to mirror it down to the bottom. Okay, at 180, we were sitting at 0, so that's just going to move along the axis there. Okay, and let's do this with each of the points. So we're going to shift it and mirror wherever we can. Okay, so I shifted all the points I could shift that fit inside my domain, and now I'm sitting with a graph like this. Okay, but I'm not going to get my marks because I've got some missing bits of information here. So in order to do that, in order to finish the graph, I'm going to need to pick up my calculator now, and I'm going to need to say, okay, what exactly is the point that I need to plot on this minus 270 line here? So I type into the calculator minus sign, minus 270 plus 30, and it gives me a value there of minus 0,867. Okay, so I'm going to then plot around about here is my point. Okay, and a lot of times they'll actually say to us that you get a mark for the end point. So minus 270 and minus 0,87. There we go. And then I'm going to do the exact same thing on the other side, but with a positive 270, and that gives me then just the positive of that exact point there. So I can then plot and say, well, that's 270 degrees and 0,87. Okay, and then it's a good habit to be in to label your turning points, to label your intercepts with the axes. Okay, and because this one has shifted up so much, there's a load of labeling to be done. So there we have it. So often we are covered. If our axes are labeled, then generally all the points are labeled. But because we shifted it, I needed to come here and label on the x-axis all of these other points. Okay. On the y-axis, I popped a 0 into my calculator just to see, that gives me minus a half, so I could label that point. And then finally, we label our graph. Y is equal to minus sine theta plus 30 degrees. And there we have it, a nice intro to all that we need to know about trig graphs.